welcome you all to session 3 of the chapter Ray Optics. When you go to the swimming pool, the base of the swimming pool appears to be raised. When you keep your legs in the water, you feel that the base of the swimming pool appears to be raised. When you dip a pencil inside a glass of water, it appears to be bent. Stars at the night appears to twinkle even though stars do not twinkle. We can see the light even before the sunrise, and you can see the light after the sunset. So what are the reasons for these questions? We have only one answer for these questions, that is refraction of light. So that will be the session of today, refraction of light. Refraction of light. Until and unless light moves in a medium, it always travels in a straight line. When a big obstacle comes in the middle, there will be a reflection of light. But whenever light travels in a medium, it always travels in a straight line. In this session, we will be learning what happens if a light changes the medium. So that will be the session of today. Okay, let me tell you like this. What is an optical medium? A medium in which light travels is called as optical medium. Okay, before I go with the refraction of light, let me tell you what are the types of optical medium, then I will be moving on to this phenomenon here. Okay, optical medium, let me tell like this, let me call it as optical medium, right? A medium in which light travels, that medium is called as optical medium. For example, light travels in air is an optical medium. Light travels in water, light travels in glass. So those all are the mediums in which the light travels, right? So those mediums are called as optical medium, right? So today's session will be what happens if light changes the optical medium, right? Okay, that is why before I go with that, let me tell you what are the types of optical medium. There are two types of optical medium or optical media. Let me tell you like this. So there are two types. The first one, that is denser medium, and the second type of optical medium is a rarer medium. Okay, there are two types of optical medium. One is denser medium and another one is a rarer medium, right? So what is denser medium? It is a medium in which light travels slower. For example, if this is a medium, let me tell you, this is a medium, here the light travels here, right? For example, light travels here. If the light travels slower in the medium, then that kind of medium is called as denser medium, right? Okay, let me tell you, light travels slower. If in the medium light travels slower, then that kind of medium is called as denser medium, right? For example, what is the rarer medium? Let me tell you. Let me differentiate the types of medium depending upon the speed of light. We know that the speed of light in vacuum is 3 × 10⁸ meter per second. But what happens if it travels in other medium? Okay, when it travels in this medium, right? If light travels faster, right? If light travels faster, then that kind of medium is called as a rarer medium, right? Okay, if light travels slower, then it is called as denser medium. If light travels faster, then it is called as a rarer medium. Okay, for example, if the light travels from air to glass, the speed decreases. So glass is a denser medium compared to that of air here, right? For example, if I am taking, this is glass here, this is water, and if I am taking here, if a light travels faster comparative to the other medium, then that kind of medium is called as rarer medium. Okay, and don't confuse with denser and rarer. I use the word called denser and rarer. It is very different from the density what you have learned, right? For example, density is mass by volume, that is different. Okay, I am not speaking about density, I am speaking about optical density. There is a lot of difference between density and optical density. For example, if I am taking like this here, for example, if I am taking water and oil here, which is more denser, As oil floats on water, water is more denser than oil, right? Let us consider what happens if a ray of light travels from water to oil. Let us check it out, right? Okay, let me take a select this, and there is water here. Let me take, there is water and there is oil here, right? Okay, let me consider this is oil and this is water. Let me keep a bulb here, right? Okay, ray of light travels from water to oil. Let us check it out. What happens to the speed, and let me decide, is it a rarer medium or a denser medium, right? The speed of the light when it travels from water to oil, speed decreases. Speed decreases. If speed decreases, then that kind of medium is called as denser medium, right? So oil is which medium now here? It is a denser medium, and water is which medium now here? It is a rarer medium. Do you understand, right? I am just speaking about the speed of light, right? Actually that light does not travel in a straight line, but for instance just I am comparing the speed of light now, right? If speed of light decreases, then that kind of medium is called as denser medium. Okay, let me conclude like this. Oil is more optical denser than that of water, even though water is more mass denser than oil, right? So there is no connection between mass density and optical density, right? So whenever we speak about optical density, we see only the speed of light. If speed of light increases, then it is a rarer medium. If speed of light decreases, then it is a denser medium, right? So rarer and denser medium depends upon the speed of light. Okay, now there must be one property which differentiates these two types of medium, right? So let me tell you that there is a property called a refractive index. Okay, we will be learning much about this property later, right? That is the refractive index, right? Refractive index, it is denoted by small letter n or mu here, right? Okay, the refractive index differentiates the types of medium, right? Okay. Let me tell you one concept here. Later on we will be discussing much about that now here. If refractive index is more, then that kind of material is called as denser medium. If refractive index is less, then that kind of medium is called as rarer medium, right? So for example, if I am speaking about air and if I am speaking about glass, air's refractive index is 1, glass is 1.5. Right, if I am considering like this, then which is more denser medium? The glass is more denser than that of air, right? By knowing the refractive index, we can decide is it a rarer medium or denser medium, right? Okay, how to calculate this? That all things we will be learning in this chapter, right? Okay, so there are two kinds of medium, that is rarer medium and denser medium. Now let us move on to the phenomena, that is refraction of light. When a ray of light travels from one medium to another medium, what happens? The light ray bends, and that bending of light is called as refraction of light. In simple, let me tell you, refraction of light is nothing but bending of lights. When does the light bend? When it travels from one medium to another. Okay, let me state what is refraction of light. It is the phenomena in which, okay, let me tell like this. It is the phenomena of bending of a ray of light. It is the phenomena of bending of a ray of light when it travels from one medium to another. One medium to another. It is nothing but one optical medium to another optical medium, right? The phenomena of bending of a ray of light when it travels from one medium to another is called refraction of light. It is called as refraction of light. Okay, simple. What is refraction of light? It is nothing but bending of light when it travels from one medium to another. Okay, let me take like this. When I speak about moving of light from one medium to another, there are two types of medium. We already studied it. Let me take like that now. Okay, let me first check it out like this. Okay, there are two medium. Okay, first let me take a rarer this side. this is a rarer medium, and let me take this is a denser medium. Okay, there are two types of medium, one is rarer and another one is denser, right? Okay, when a ray of light travels from rarer to denser, let me take this ray. Okay, this is a ray of light. That is called as incident ray. Okay, at this point of incidence, let me draw a normal, right? A ray which is a line which is perpendicular to the point of incidence, right? To the surface. Let me take at the point of incidence to the surface, that is called as normal, right? Okay, if the medium was a single medium, then the light would travel in a straight line, but it is not now here. It is traveling from one medium to another. If it travels from a rarer to denser medium, what happens to the speed here? Speed decreases, right? As speed decreases, it bends towards the normal. Do you understand? Speed decreases and it bends towards the normal. Whenever a ray of light travels from rarer to denser medium, speed decreases and the ray bends towards the normal, right? Actually, the ray should move like this if it is traveling in a single medium. As it is changing the medium, therefore the light bends. That is called as a refraction of light, right? Where does it bend? There are two types of bending. One is towards the normal and another one is away from the normal, right? When it travels from rarer to denser medium, speed decreases. As speed decreases, it bends towards the normal, right? Okay, here the light bends towards the normal. Do you understand this? Light bends towards the normal. Okay, do you understand? The light bends towards the normal. Do remember this. When a light ray travels from rarer to denser medium, speed decreases and the light ray bends towards the normal. Right? Okay. What happens if a ray of light travels from denser to rarer medium? If I am taking denser to rarer medium, right? Okay. If I am taking this is a ray of light. Right? Okay, at this point of incidence, let me draw a line perpendicular to the surface, and that is normal. Right? Okay, now, if a ray of light travels from denser to rarer medium, the speed must increase. Right? As speed increases, it goes away from the normal, right? Okay, it moves away from the normal. Right? It moves towards the normal here when it travels from rarer to denser. When it moves from denser to rarer medium, it moves away from the normal. As the speed increases, it moves away from the normal. Right? So, here let me state like this: a light bends away from the normal. Light bends away from the normal. Do you understand here? If a ray of light travels from denser to rarer medium, light bends away from the normal and it bends towards normal when it moves from rarer to denser medium. Okay. In simple words, let me tell like this: refraction of light is nothing but bending of light. There are two types of bending. One bending is towards the normal, another one bending is away from the normal. When the right ray travels from rarer to denser medium, it moves towards the normal and the speed decreases here. Right? When a ray of light travels from denser to rarer medium, the speed increases and it moves away from the normal. Right? These two things you need to remember. Right? Okay. And another one note point that you need to remember here is, so in a refraction of light, one thing what we need to remember. Okay. Say, let me write that in terms of notes. When a ray of light, when a light travels from one medium to another, okay, see here, when a ray of light travels from one medium to another, what changes? Speed changes, that we know, but one physical quantity remains constant. Do you remember? When a ray of light travels from one medium to another, frequency remains constant. Do you understand this? This is very important to know about refraction of light. Whenever a ray of light travels from one medium to another medium, one physical quantity which remains same, right? What is that physical quantity? That is frequency remains same, right? Frequency is always related to the color of the light, right? If you keep an yellow color bulb inside the water, you can see a yellow color itself, right? So the color of the light will not change. Do you understand? Right? If there is a tank and if you keep a red color bulb, you can see the red light itself. The color will not change. Why the color will not change? Because the frequency remains constant in case of refraction of light. Then what changes? Of course, the velocity changes. And we know there is something relationship between velocity and the frequency and wavelength, right? So V is equal to F lambda. V is equal to nu lambda, we know, right? This term is constant. Then what changes? Velocity and wavelength. Do you remember? Velocity and wavelength changes when a ray of light travels from one medium to another, right? Of course, velocity changes and also the wavelength will change, right? If velocity increases, and again wavelength must also increase, because this remains what we say here, constant, right? So do you remember, when a ray of light travels from one medium to another, frequency remains constant, but velocity and wavelength changes. Okay, now let us find what are the laws which govern refraction of light. Okay, that we will be learning under laws of refraction. As we have learned laws of reflection, now we will be learning about laws of refraction. Okay, let me take those laws now here, right? Now the next is laws of refraction. So the laws governing refraction of light, let me write here. Okay, now let me take like this, that is laws of refraction. Laws of refraction. Okay, the laws which govern refraction of light. Laws of refraction. Okay, let me consider a ray of light travels from one medium to another. Okay, this is let me take this is the line which divides these two medium. Okay, let me consider like this, it is a rarer medium, and let me take it is a denser medium, right? For example, air and water, let me take like this, right? A ray of light falls on it, and this ray is called as incident ray, right? This ray is called as incident ray. At the point of incidence, let me draw the perpendicular line, and that line is called as normal, right? Now if a ray of light traveling from one medium to another, what happens? It bends. Where it bends? Let us check it out. If a ray of light travels from rarer to denser medium, the speed of light decreases. As speed of light decreases, it bends towards the normal. Okay, it bends towards the normal, it bends like this, right? Okay, the angle between incident ray and normal, let me call it as angle of incidence, right? What is angle of refraction? This is angle, this is refracted. Okay, let me introduce to you. This ray is called as refracted ray. This ray is called as refracted ray. What is angle of refraction? It is the angle between refracted ray and normal. Do you understand? Always the angles are measured from normal, right? The angle between incident ray and normal is angle of incidence. The angle between refracted ray and normal is angle of refraction. Okay, now let us understand what are these laws. Okay, let me go with the first law. The first law states that the incident ray, refracted ray and the normal, okay, incident ray, refracted ray and the normal at the point of incidence, okay, see here, the incident ray, refracted ray and the normal at the point of incidence all lie in the same plane. Do you understand this? This is the first one, right? The incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane, right? Incident ray, normal and refracted ray all lie in the same plane. The meaning of this is, if incident ray is on the board, normal is also on the board, refracted ray is also on the board, right? There cannot be a case that incident ray falls like this and refracted ray will be out of the board, right? No, incident ray, refracted ray and normal all lie in a single plane, right? If incident ray is like this, right, if this is a plane now here, right, if incident ray is like this, normal will also be here only and refracted ray also will be in that plane itself, right? All these three lie in the same plane. That is the first law, right? The incident ray, refracted ray and the normal at the point of incidence all lie in the same plane, right? Let me go with the second law. Second law tells you about what is the relation between angle of incidence and angle of refraction, right? Here if you check it out, these two are not equal. Then how they are related, right? Let me tell you, right? The ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction, Let me find what is the relation between angle of incidence and angle of refraction. the ratio of sine of angle of incidence to the sine of angle of refraction is always constant, right? Okay, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of medium, for a given pair of media and for given wavelength of light. Okay, do you understand this? Given wavelength of light. Okay, see. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant. The sine I divided by sine R is a constant, and it is constant for a given pair of media and for a given wavelength of light. And this is called as, and this law is called as Snell's law. Do you understand this? We will be naming the second law of refraction as Snell's law. Right? Okay, the second law of refraction itself is a Snell's law, that is sine I by sine R equal to constant. Okay, by this we came to know that sine of I divided by sine R, right? Sine of angle of incidence to the sine angle of refraction is a constant, and this is called as Snell's law. Right? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of medium, right? If you change the pair of medium, and this constant will also change now, right? It is a constant for a given pair of medium and for a given wavelength of light, means for a given color of light. If you change the color of light, again this constant will change now, right? For a given pair of medium and for a given color of light, or for a given wavelength of light, the ratio always remains constant, and this constant is called as refractive index. Refractive index for the pair of medium, for the pair of media. Okay, same. It is the refractive index for the pair of media, that is the constant, right? For a pair of media and for the given wavelength of light, the ratio of sine I by sine R is equal to constant, and this law is called as Snell's law, right? So just let me compare the reflection with the refraction. First law is same for both now here, right? There is reflected ray, there is refracted ray. That is the difference now, right? If you go with the second law, their angle of incidence is equal to angle of reflection in case of reflection, but in case of refraction, sine I by sine R equal to constant. And what is that constant? That constant is called as refractive index for the pair of medium, and that constant is equal to refractive index. Right, so sine I by sine R is equal to constant, and that constant is called as refractive index for the pair of medium, and this law is called as Snell's law. So these two are the laws which govern the refraction of light. Now let us understand about refractive index in detail now here. Let us move on to the refractive index now here. Refractive index. Refractive index. Okay, refractive index of a medium. Already I have told you that when I speak about the speed of light in a medium, okay, first of all, let me define refractive index in terms of speed of light itself, right? Okay, refractive index is defined as the ratio of speed of light in vacuum, to the speed of light in the medium. Okay, see here, refractive index, let me define like this. Refractive index of a medium, if I am speaking about a single medium, let me define it. Refractive index of a medium is defined as speed of light in vacuum to the speed of light in the medium, right? Refractive index, it is denoted by small letter n, right? Okay, let me tell you, it is the ratio of speed of light in vacuum. First we need to take speed of light in vacuum. We know what is speed of light in vacuum, 3 × 10⁸ meter per second, right? Again, it is the speed of light in what we say here, medium. Let me take like this, n. Speed of light in vacuum, we know it is denoted by small letter c, and the speed of light in medium, let me call it as v, that is speed of light in medium, and c, you know, it is speed of light in air or vacuum, it is denoted by c, right? Refractive index of a single medium is the ratio of speed of light in vacuum to the speed of light in the medium, right? Okay, let me tell you like this. Refractive index are of two types. Okay, let me define like this. Refractive index are of two types. One is absolute refractive index, and another one is relative refractive index. Okay, one is absolute refractive index and one is relative refractive index. The refractive index of a single medium which I am speaking, that is absolute refractive index. Absolute refractive index. The refractive index which I have discussed here, that is absolute refractive index. Means it is a refractive index of a single medium, and it is always compared to the speed of light in vacuum. Do you remember? If I am speaking speed of light, if I say refractive index of water, it is understood that I am comparing water with the air or vacuum, right? If I am speaking the refractive index of glass, means I am comparing the speed of light in glass with the speed of light in vacuum. If I compare a medium, the speed of light in a medium with the speed of light in vacuum, that refractive index is called as absolute refractive index or simply refractive index. Did you understand, right? When I speak about refractive index of glass, it is understood that it is absolute refractive index, it is compared with air or vacuum, right? Okay, and there is another refractive index, that is a relative refractive index. Okay, I am speaking about a relative refractive index. Okay, I am taking, if I am taking two medium, right? Okay, I am not comparing with the air or vacuum, I am taking two different medium. That time there is one refractive index which arises, that is called as relative refractive index. Okay, what is relative refractive index? It is refractive index of a medium with respect to another medium, is called relative refractive index. We call it as a relative refractive index. So what is relative refractive index? Refractive index of a medium with respect to another medium, right? So if I am comparing one medium with respect to another medium, that kind of refractive index is called as relative refractive index. Means I am comparing two medium here, right? Okay, let me write like this. Refractive index of medium 1 with respect to medium 2. Let me take like this. Refractive index of medium 1 with respect to medium 2. Let me take like this. Means it is denoted by refractive index of medium 1 with respect to medium 2. Right? So I will be denoting like this. There are two medium now here, right? Refractive index of 1 with respect to refractive index of 2 now here, right? So sorry, refractive index of 1 with respect to medium 2 now here, right? Okay. This can be written as n1 divided by n2. Do you remember? n12, it is the ratio of refractive index of medium 1 with respect to refractive index of medium 2. Right? Okay. And we know that if refractive index increases, speed decreases. Okay. So let me write like this. This is also equal to V2 divided by V1. Right? It's the reverse. Right? If refractive index increases, speed decreases. They are inversely proportional to each other. Refractive index and speed are inversely proportional to each other. That is why I can write like this. N12 is equal to N1 by N2, that equal to V2 divided by V1. Okay, once again, refractive index are of two types, absolute refractive index and relative refractive index. Absolute refractive index means I am speaking refractive index of one medium with respect to air or vacuum, right? If I take N1, it is absolute refractive index. If I am taking N2, it is absolute refractive index. Means I am comparing with air or vacuum, speed of light in air or vacuum, right? If I write like this, N12, that is the refractive index of 1 with respect to 2 now, right? Okay, so this kind of refractive index is called as a relative refractive index, right? Okay, now let me give an example for this and you can understand. Do remember, refractive index is inversely proportional to the speed of light. If refractive index increases, speed of light decreases. Okay, let me give one example for a relative refractive index. Okay, let me write like this. Okay, if I'm considering this is water, right? Let me take this is water again, and let me take this is water and this is what we say here, air, right? When a ray of light falls here, let me take, when a ray of light falls here, right? This is incident ray, and the line which is perpendicular to the plane, that is called as normal, and this is angle of incidence, right? It is traveling from rarer medium to denser medium. If a ray of light travels from rarer to denser, speed decreases. When speed decreases, it moves towards the normal, right? Okay, it moves towards the normal. If I'm taking like this, this is angle of refraction, right? So let me call this is the refractive index of air and the refractive index of water, right? This is the refractive index of air, let me call Na, and refractive index of water, let me call Nw. Okay, let me find what is the refractive index of water with respect to air. Okay, let me find relative refractive index. How to calculate this? Refractive index of water with respect to air. Okay, this can be written as, first refractive index of water, first you need to take this in the numerator and this you need to take in the denominator. Nw with respect to A is Nw divided by Na. If I want to write in terms of speed of light, okay, we know they are inversely proportional to each other, Va divided by Vw. Right, let me take velocity of light in air to the velocity of light in water, right? So do remember, this is refractive index is called as a relative refractive index, right? Refractive index are two types, absolute and relative, and you need to understand what are the differences between these two, right? Whenever I speak about absolute refractive index, always it is compared with air or vacuum, right? Okay, these are the two types, right? So this is all about a refractive index. Now let us find what are the consequences of a refraction of light. Let me take like this. Consequences of refraction of light. Okay, next concept is about consequences of refraction of light. Refraction of light. Let me take consequences of refraction of light. So what are the consequences, right? So if reflection of light takes place, what happens? Okay, there are two main consequences of refraction of light, that is lateral shift. The first one is lateral shift and the second one is normal shift. Okay, these two are consequences of refraction of light. Okay, so there are two consequences of refraction of light, one is lateral shift and another one is normal shift, and we will be learning these two in detail. Okay, let me begin with the first one, that is lateral shift, right? Okay, let me start with the first one, that is lateral shift. Okay, let me take like this. The next subheading is about lateral shift. Okay, what is the meaning of lateral shift? Shifting sidewise laterally, right? Okay, that is called as lateral shift. Okay, let us take a glass slab and let us understand about this lateral shift. Okay, let me consider a glass slab now here, right, where you can see the lateral shift. Okay, let me take a rectangular glass slab. So this is a glass slab, and the thickness of the glass slab, let me call it as T. Okay, there is a glass slab, you know, a rectangular glass slab now here. Okay, and the thickness of the rectangular glass slab, let me take it as T now here, right? Okay, what is present here? Air. What is this now here? Glass. And this is what now here? Air, right? Everything is air outside, and this is about the glass. Okay, this is about the glass, and what is here now here? It is air now here, right? Now what happens if a ray of light travels from air to glass now here? Let us check it out. Okay, let me take, this is a ray of light which is incidenting on the glass, right? Which ray is this is called? This is called as incident ray, right? Okay, let me imagine what happens if glass is not there here, right? Okay, if I remove the glass, actually the ray of light, how actually it goes now here, right? If I'm taking like this, okay, let me take a little bit slant so that you can understand clearly here. Okay, let me take like this. This is a ray of light which is inciding on the glass now here. Okay, if I remove the glass, how actually the ray of light moves now here, right? It moves in a straight line, right? It moves in a straight line like this, right? Okay, since there is a glass at this point of incidence, let me draw the normal. Okay, where actually the ray of light moves now here, right? Okay, it is traveling from air to glass, means it is traveling from rarer medium to denser medium. What happens to the speed? Decreases. If speed decreases, it moves towards the normal now here, right? Okay, it moves towards the normal. Let me take like this. It moves towards the normal, and it is traveling a straight line in this medium, right? It moves towards the normal. And what is this ray is called? It is called as refracted ray. right? Okay, at this point of incidence, let me draw a normal now here, right? Now, what happens? The ray of light is traveling from glass to air. Again, this is what now here? Air. It is traveling from glass to air, means it is traveling from denser medium to rarer medium, right? When it is traveling from denser to rarer medium, means its speed must increase. If speed increases, the ray of light moves away from the normal, right? Okay, if I am taking like this, it moves away from the normal, means it moves like this. This is, and this ray is called as emergent ray. Okay, once again, this is called as incident ray, this is called as a refracted ray, and this is called as a emergent ray, right? Okay, this is called as angle of incidence, and this is called as angle of refraction. As these two are normal, this angle is also angle of refraction itself from here, right? Okay, now let us imagine if there is no glass here. If there is no glass here, the light would have been gone like this, right? Okay, the light would have been gone like this if there is no glass here. Okay, so this is called as incident ray, this is called as refracted ray, and this is called as emergent ray, right? If you are seeing from this side, right? If you are seeing a substance which is kept here, okay, let me take a if I am taking a box is kept here, right? If I am seeing from this side, this box appears to be shifted this way, right? Okay, if I am taking, there is one object kept here, it appears to come from, the person who is seeing from this side appears to come from this side, and this shifting is called as lateral shift. And the perpendicular distance between these two lines, this is incident ray and this is emergent ray, and this perpendicular distance is called as lateral shift. Okay, so let me define what is lateral shift. When a ray of light, okay, when a ray of light travels through a rectangular glass slab, right? Okay, when a ray of light travels through a rectangular glass slab, okay, when a ray of light travels through a rectangular glass slab, the perpendicular distance, okay, see here, this is the perpendicular distance. The perpendicular distance between incident ray and, okay, come on, tell me, the perpendicular distance between, which is this ray, incident ray, and which is this ray, emergent ray. The perpendicular distance between incident ray and emergent ray is called lateral shift. Lateral shift. Do you understand what is lateral shift? Shifting sidewise, shifting laterally, that is called as lateral shift. Right, the perpendicular distance between incident ray and emergent ray when a ray of light travels through a glass slab. So this perpendicular distance is called as lateral shift. Right, whenever you see this object from this side, it appears to come from here. Right, if I am seeing this object through this glass slab, it will look like it is shifted laterally. That is why the name lateral shift. How much the shift is? The shift is equal to the perpendicular distance between incident ray and emergent ray. That is called as the lateral shift. And how to calculate lateral shift? There is no derivation, directly we need to mention. Lateral shift, LS, is T sine of I minus R divided by cos R. There is no derivation for this, just you need to remember how to calculate lateral shift. How much shift will be there? It depends upon the thickness of the glass slab also, right? So lateral shift is equal to T sine of I minus R divided by cos R. T, that is thickness now here, sine. I and R, what are I and I? I is angle of incidence, R is angle of refraction. Do remember this formula. What is the formula for lateral shift? T sine of I minus R divided by cos R. This is how you can calculate lateral shift when a ray of light travels from air to the glass slab, and this kind of shifting sidewise, right, shifting sidewise, that is called as lateral shift, and this is the one of the consequences of refraction of lights. Now let us move on to the second one, that is normal shifts, right? Okay, so this ray diagram is important, and what is the lateral shift and what is the equation for it now here, right? So do remember this. This is about lateral shifts. right? The consequence of refraction of light is the object appears to shift laterally when viewed through a rectangular glass slab, right? So that shifting is called as lateral shift, and it is one of the consequences of refraction of light. Let me go with the second consequence, that is normal shift. Okay, let me go with the second one, that is normal shift. Okay, the next consequence of refraction of light, that is normal shift. Okay, when actually you can see this normal shift, let us check it out now here, right? Okay, if I'm taking water here, if I'm taking like this, if I'm taking water, and let me keep an object here, this is an object, let me keep a coin at the bottom of the beaker like this now here, right? Okay, now if there is object here, light ray, okay, one thing what you need to understand, light ray always travels from object now here, right, from object itself, right? And we know that if ray of light travels perpendicular to the surface, right, if a ray of light travels like this, it will not bend, it moves like this itself. Do you understand? If a ray of light moves perpendicular, it will not bend here, right? So one thing what you need to understand is refraction of light, that is bending of light, does not take place in this condition, right? If a ray of light falls exactly at the perpendicular, it will move forward like this itself, right? Do you understand this? And if I am moving like this, it will not bend, it moves forward, right? Okay, this is one ray I took. Let me take another one ray now here, okay? Another ray, let me take like this now here. This is the ray of light, because I'm seeing from the outside, right? I'm seeing this coin from outside, right? If I'm taking a ray like this, this is a ray which I'm taking like, right? Ray of light. Okay, come on, tell me what happens to this ray of light. The ray of light is traveling from water to air, means it is traveling from denser to rarer medium. Okay, let me take a normal here. Now it is traveling from denser to rarer. What happens to the speed? Speed increases. If speed increases, where does a ray of light go? It goes away from the normal, right? It moves away from the normal like this. A person who is seeing from this side, right? If he is seeing this coin from this side, this coin appears to come from this point. Let me take this. This is the coin, right? He sees the coin a little bit raised. Did you understand, right? If he is seeing from outside, he sees like, okay, the light travels in a straight line, and he sees the coin to be shifted normally. And this kind of shifting is called as normal shift, right? Do you understand? This is the normal shift now here, right? Okay. Let me call this as thickness, right? Thickness of the what we say now here, water, or let me call this depth as a real depth. Let me use two words here. One is real depth and another one is apparent depth. Real means, okay, where actually the object is, right? The distance are always measured from surface of water. So what is this now here? What is this distance? This is called as a real depth, right? And what actually appears, this distance is called as apparent depth. Apparent depth, right? Okay, this is a real depth and this is called as apparent depth. Okay, it appears to be raised, and this distance is called as apparent depth, and this is called as a real depth, right? Okay, and let me tell you one thing here. If I am calculating what is the refractive index of this water here, right? Refractive index can be calculated by like there is another formula to find the refractive index, that is real depth divided by apparent depth. Apparent depth. Okay, one formula you need to understand here, real depth divided by apparent depth. So this is one of the formula for refractive index. Okay, when we speak about normal shift, there is one formula for refractive index, that is real depth divided by apparent depth. We have already seen a formula that speed of light in vacuum to the speed of light in material. In the similar manner, refractive index, the formula is real depth divided by apparent depth, and this kind of shifting is called as normal shifts, right? How much is normal shift? Let me check it out now, right? Normal shift. What is normal shift? Do you remember? Normal shift is an apparent shift. Actually, the shift does not take place here, right? Okay. The apparent shift in the position of the object in the position of the object. Okay, see here, the apparent shift in the position of the object. The apparent shift in the position of the object along the normal. Okay, do you remember, normal shift is the apparent shift of the position of the object along the normal, right? Okay, along the normal there is an apparent shift, right? The apparent shift in the position of an object along the normal when viewed from another medium. Okay, the apparent shift in the position of an object along the normal when viewed from another medium is called normal shift, and it is called normal shift. Okay, what is normal shift? Once again, what is normal shift? It is an apparent shift. Okay, this is the shifting which took place here, right? So this is the shift. Let me call normal shift, let me call it as ns, right? So what is normal shift? How to calculate normal shift? Let us understand it, right? So normal shift, that is the apparent shift of the position of the object normally, right, along the normal when viewed from another medium, right? When we are viewing from another medium, there is an apparent shift, and that shift is called as normal shift. And there is a formula to calculate normal shift, that is ns equal to t1 minus 1 by n. Okay, there is no again derivation for this normal shift, but there is a formula that you need to remember. That is normal shift ns equal to t into bracket 1 minus 1 by n. What is the t? That is thickness, or shall I call t as real depth, right? T or thickness of the water, or let me call it as real depth, into bracket 1 minus 1 by n. So what is n? Refractive index of this medium, right? In this medium, what is the refractive index of this medium? Let me call it as n, right? How to calculate this? Again, we know we can calculate the refractive index by the ratio of real depth divided by apparent depth. Okay, do you remember this ray diagram, right? First ray, let me take normal, it moves forward here, right? Let me take, we want two rays, because we know the image is formed when two rays meet here, right? So let me take another one ray, and it moves away. As it moves away, he can see the object in this way now, right? So these two rays meet at this point, and this is where the image is formed, and the position of the object has been shifted, right? Okay, it appears to shift now here. That apparent shift is called as normal shift. So in the examination, do you remember what is the ray diagram for normal shift, and what is the definition for normal shift, and what is the formula for it now here, right? So it is the apparent shift of the position of an object normally when viewed from another medium, and that shift is called as normal shift. Okay, there are two consequences of refraction of light. One is lateral shift and another one is normal shift, and we have discussed about these two in detail, right? Thank you.